takes
The question is,
over the pump.
how do we go about finding out all the information we need to know to be able to analyze a pump? Well, from a topog map, we can know what the water surface is. We can know what the highest point in the field is, and those are available all over the nation. You can find a topog map for every square foot of this country.
And then the pump will say,
and that'll give you,
and then you just pick it out per.
Then that gives you the elevation or the altitude. You know how high above sea level you are.
Right.
Okay, you may have to measure the temperature of the water. You do that with the thermometer, and that's a pretty simple thing to do. But yeah, you may have to do that. There are lots of hot water sources out there. If you're pumping liquids out of a food processing plant, for example, it may be very hot water. There are geothermal water sources that are being used for irrigation that have hot water. We have a well 15 miles to the west of Walla Walla over here that runs 102 degrees over just south of Loudon. It's a great deal for frost protection. Man, they got hot water, and it's perfect for frost protection. But their pump has to be, you have to be aware of that for its characteristics of the pump. In this case, it's a turbine. It's down, the bowls are down in the well itself. So that kind of information, you have to get field data on it, yeah. So you do have to do some work. Then you look up the pump curve, and you'll notice in your package you do have a pump curve, and it talks about NPSH. And we're going to do that here within the hour. We hit that one more time. And we'll talk about that NPSH for each individual pump. Okay? That's a tough concept. In the pumps class, that's 2 days worth of lecture just to go through the calculations of being able to do NPSH valuation. Last but not least in the process of a pump is we need to find out how many horsepower the thing's going to need. And so we have to be able to calculate the brake horsepower. Now the brake horsepower takes into account the efficiency of the unit. We could just calculate what we call water horsepower, but we really want to know what the brake horsepower is. And so the brake horsepower, and the reason they use the word brake is in the old days they literally would have an engine running, and then they would take a big long rod and start pulling on the end of it and braking on the shaft of that motor, acting as a brake. As the motor spun, they would pull down on that and put more and more load on it, foot-pounds of load. So many feet out, so many pounds pulling down on it, you have a load, a foot-pound load. And the more you braked it, they could evaluate how much the performance of the engine was. So that's where they come up with the term brake horsepower. They put an artificial brake, not an artificial, a real live arm brake on the motor to do the testing. And so that's where they come up with the term brake horsepower. Don't let that confuse you. We normally just think of it as horsepower. We just assume it's horsepower, what we need. Well, the horsepower can be written this way. It's the gallons per minute times the total dynamic head divided by a constant 3960 times the efficiency of the unit of the pump itself. Now you got the efficiency of the motor and of the hydraulic characteristics inside the pump. No pump is a perfect operation. There's no such thing as perpetual motion. We have mechanical and electrical losses in a pump and hydraulic losses. The electric motor is only going to be so much percent efficient. The new motors can be over 90% efficient. The pump itself is going to have some wear parts. It's going to have maybe a bearing or two in it, a packing area in it that are going to cause mechanical efficiency losses. And then there's going to be some turbulence inside the impeller itself that causes some hydraulic inefficiencies. So that value then, we get an efficiency value for the pump. And we can find that from every pump curve, and we're going to look at pump curves here in just a minute where we can dig that information out. But we can calculate the horsepower by simply knowing then the flow in gallons per minute times the total dynamic head in feet times or divided by a constant 3960, that's just a number cruncher to get the units all right, times the efficiency, or divided by the efficiency, it's on the bottom. And that gives us brake horsepower. So it's really quick and easy to calculate. Very, very simplistic. So we know how big a pump we need at a given site.